Hi, and welcome to Lesson 5.6, Introduction to Slope. So by the end of the lesson, you should be able to understand the slope of the line. So slope is just the steepness of the line. Right? We will refer to slope, or the letter that we use to refer to slope is a little m. Okay, and slope is always equal to the rise over the run. Okay, it's also equal to y2 minus y1 over x2 minus x1, and we could short form that to just the change, so delta y over the change, or delta x. Okay, rise is up, positive, or down, negative, and run is always going to be to the right. Just for funsies, why do we use M for slope? Because it doesn't have a letter M in it. It's used, comes from the French word monter, to go up. So slope has no units because the units divide out. So it's always just going to be a number. So how do we find the slope of a line segment? So in order to find the slope of a line on a grid, we don't care about this part. Cross this part out. We don't need it. We're going to do this over here. So on a grid, we always count the run from left to right, just like we read. Okay? So we're going to try a couple of these. So example number 1, we want to find the slope of each line on the grid. So if we look at line number 1 here, right, it rises from left to right. Okay? So from the left, we're going to start at one part of the line, go from left to right, okay? And then, so that would mean that it has a positive slope, okay? And then it rises up, okay, from the line that we drew up to the top. So this part where we go from left to right, this is our run. And in this case, right, if we just count squares, it would be 1, 2, 3, 4, 5, 6 squares. And our rise, because it's going from top to bottom, it means that it's positive, and then we're going to say it's 1, 2, 3, right? This is our rise, and it's 3 up. So remember, it's always rise over run, which means that it is 3 over 6, or 1/2. Okay, because we always want it in lowest terms. If we take a look at line number 2, okay, it falls from left to right, so this one's going to have a negative slope. So again, we're going to do our rise, right, from the top to the bottom here. So this is our rise. And if we count squares, 1, 2, 3, 4, 5, 6 again. And then our run, right, always go from left to right, and it's just 1 square. So in this case, our rise would be 6, our run is 1. Our rise is -6. Watch out for that. Because we went down, our arrow is pointing down, that means that's negative. So then our slope is just -6. Line number 3, at the bottom here, it's a horizontal line. It doesn't rise or fall from left to right. So its rise would be 0, right? We don't have a rise, but we do have a run, okay? So the rise would be 0. The run is 1, 2, 3, 4. 0 over 4, our slope is just 0. And then if we check out line 4, it doesn't run. So it has a rise, right? If we go up or down, it's 1, 2, 3, 4, 5, right, is our rise. And it has a run of 0, right? It doesn't go left to right. So our slope is 5 over 0. But we know that we can't divide anything by 0. So we're going to say that our slope is undefined. So anytime we have a vertical line, our slope is undefined. Just like anytime we have a horizontal line, our slope is going to be 0, right? So these are for horizontal lines. And this one is for a vertical line. Okay. So quick little summary here. Any line rising to the right has a positive slope. Right, just like our little face over here, right? If it goes up to the right, it has a positive slope. If it's falling to the right, it has a negative slope. Okay, so this would be our negative slope. A horizontal line has a slope of 0. Right, so our little face here. And a vertical line has an undefined slope. So that would be like your nose part. And that's why we got U for undefined. And then on our face, on our mouth, right, the zeros to remind us that horizontal lines have slopes of 0. Slope measures how steep a line is. The higher the value for a slope, it represents a steeper line. And the lower a value for slope represents a flatter line. Okay, so let's take a look at some examples here. So if we're given the slope, we want to be able to state the rise and the run. Well, remember that our slope equals rise over run. So this is a pretty simple question. Rise is always on the top. So in this first one, if slope is 3 over 4, our rise would be 3 and our run is 4. For part B, slope is 5 over 3, so rise is 5, run is 3. Part C, the slope is negative 6. Well, remember we could always write this over 1, so the rise would be negative 6, the run is 1. And then for this last one, the slope is negative 1/2. If we have a negative number, I always make it on the rise. Like we said, the run always goes from left to right, so it's always going to be positive. So in this case, my rise would be negative 1, and then my run would be 2. Okay. So we can also reduce slope, right? It should always be written in lowest terms. So we want to draw a line on the grid here that rises 12 and runs 8. So our slope would be, all right, our rise over our run, so it would be 12 over 8. Okay, so let's try and draw a line that rises 12 and runs 8. So I'm just going to pick a starting point, let's say here, and then I'm going to go up 12, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and then over, right, I'm going to run 8. 1, 2, 3, 4, 5, 6, 7, 8. So these two dots are going to be points on my line. Okay, so this is, from here, this is my 12 for my rise, and my run is 8. So now we can reduce the fraction. So if we were to reduce our fraction, right, we could say if we divide both by 2, we would have 6 over 4. And if we check that on our graph, let's see if we can get something that is still 6 over 4. So if we go from our original dot and go a rise of 6, so 1, 2, 3, 4, 5, 6, right, this would be for 6. And then if we go over 1, 2, 3, 4, it still works, right? It still works. We still have the same slope, even though our numbers for our rise and our run are actually different. It's still the same ratio. So if we go all the way down to lowest terms, right, 3 over 2. So again, I'm going to start at my bottom dot and go up 1, 2, 3. So this is my 3, and then run, whoops, that's not a very good line, over 2, right? We get that same spot here. I forgot to put a dot on this one. Okay, so the rise and the run are all ratios. They're all in proportion, right? Is the reduced form of the fraction also the slope of the line? Explain why or why not. Definitely it is. Right? Yes. It's a reduced ratio of the rise to the run. So we always want to put them in lowest terms, but whether you're given one that is or isn't in lowest terms, it would still work out the same way. Okay. Oh, pen's not going to work. Oh, there it goes. Okay, so how do we calculate slope, right? So if we're just given a line, how do we find the slope from the line, right? If we're given the slope, we could draw a line, but how do we do it the other way? So in a coordinate system, the slope of any line segment can be found if any 2 points are known. So as long as we know 2 points on the line, we can figure out what our slope is. So our rise would be the difference in the y coordinates, and the run would be the difference in the x coordinates. Okay? And as I said earlier, the slope formula, we can do the slope equals y2 minus y1 over x2 minus x1, right? Where we would have a set of points that we would have, right, x and y, and we would say that these are x1, y1, and we'd also have another set of points x2 and y2. So we're going to try this out. We're going to graph our 2 points and then find the slope using the formula. So first off, we're going to graph because we can do this. So we've got point A is 2, 1, and I'm not going to label my x and y axis with actual like numbers. I'm just going to assume that everything is 1. Okay. So for A, we have x. Right, this is x1 and this is y1, this is x2, this is y2. So x1, we go over 2, and then y1 up 1. So this is A. Oh, that's an ugly A. Okay. For B, we're going to go 1, 2, 3, 4, 5, and then 1, 2, 3. This is B. And then use your ruler. Draw your line. Okay, so what we want is the slope of this line. Now, since we drew it, we could find the slope using the rise and the run. Okay, we're going to use that to verify that we're right. We're going to try it using the equation. So our slope is y2 minus y1 over x2 minus x1. Now, I would suggest labeling your point with x1, y1, x2, y2, just to avoid any mistakes. So if I look over here, my y2 was 3, y1 is 1, so 3 minus 1, x2 was 5, and x1 is 2. So now I just have to subtract. 3 minus 1 is 2, 5 minus 2 is 3, so my slope should be 2 over 3. So now let's actually check in our graph. So if I were to rise up 2 and then run right 3, we should have the exact same slope, which we do. All right, so let's try a second one here. So this time we've got m is negative 3, 4. So 1, 2, 3, 1, 2, 3, 4. There's my m. And then n is negative 1 for x, and then negative 2 for y. So then this can be my n. And then I'm going to draw a line using my ruler. Okay, make sure you extend your line well past the points. So again, let's try to calculate the slope using our formula. y2 minus y1 over x2 minus x1. So I'm going to label again. So this is x1, y1, and x2, y2. So y2 is negative 2 minus y1 is 4. And then x2 is negative 1 minus x1 is negative 3. Make sure the two negatives, that second one should be in brackets. So negative 2 minus 4 is negative 6. 1 minus negative 3 is like saying negative 1 plus 3, and that's 2. So negative 6 divided by 2 is negative 3, because we always want it in lowest terms. So now we could try to see if our slope is correct, right? So in this one, we got negative 6 over 2. So technically, if we go down 6, 1, 2, 3, 4, 5, 6, right? We go down 6 here, and then to the right 2. So this is our negative 6, so this is our positive 2. Our rise and run match up, right? The reduced version would be the negative 3, which we could also do if we went just down 3 and over 1, it would work. Okay, so this time we're going to try and use our formula to find a missing value. So we have this line that's joining point M, negative 2, 6, to point N, 5, K. It has a slope of negative 1. We need to find the value of K. So I'm still just going to write my formula that I know. So slope is y2 minus y1 over x2 minus x1. And then I'm going to put in what I know. I'm going to label my coordinates up here just to be safe. And I know my slope is negative 1. So M is negative 1, y2 is k, y1 is 6, x2 is 5, minus x1 is negative 2. So negative 1 equals k minus 6, and then we can simplify on the bottom here. We've got 5 minus negative 2, so 5 plus 2 is 7. We want to get rid of this denominator here, so multiply both sides by 7. So negative 7 equals k minus 6. We need to move that 6 over, make it positive, and now k equals negative 1, right? So we can say, therefore, k equals negative 1, and point N would be 5, negative 1. Right? We could also check this using left side, right side. And then for the last one, we want to draw lines with the following slopes, and we're going to try and use a different color for each line and show our work. Ooh, this is kind of blurry. There. I think I got enough room here. Okay. There. So the first one, if you can read that blur, is m equals a half, right? So our slope is 1/2. So we can pick any spot on the grid. It doesn't really matter. They didn't give us XY axis, so we can just kind of go wherever we want. So I'm just going to pick a point and draw a dot. And then this is my rise. This is my run. So I'm going to rise up 1 and then over 2. Put a dot there. And then draw a line between my 2 points. Right? So this is my slope equals 1/2. For this one, right, we've got rise over run. So this is my slope equals just 2. This is an equal sign. So that's saying 2 over 1. So again, I'm just going to kind of pick a point here. I don't know, right here, I guess. So if my rise is 2, 1, 2, and then my run is 1, so right there. And then we can do the 2 dots. Draw a line. Oh, that was kind of a bad line. Oh no. There we go. Fix my line there. That's a bit better. This is my slope equals 2. Okay. I'll try another color here. So this one, my slope is negative 5 over 6. So again, we've got rise over run. So my rise is going to be negative. So I'm just going to pick a point kind of up here. So if my rise is -5, that means I want to go down 1, 2, 3, 4, 5 spots. And then my run is 6. 1, 2, 3, 4, 5, 6. There's my point. So draw my line between my dots. And this one would be my slope is -5/6. Okay, I don't know, let's do a color pink. So this one, my slope is -3. So we've got rise over run. And remember, -3/1. So pick a point, I don't know, somewhere over here. Now my rise is -3, so we're going down 1, 2, 3, and then my run is just 1. So put my dot there. And draw your line. So this is my slope equals -3. And then one more. Woo! Whoops. Uh-oh. There we go. Okay, so this one, my slope is just 3. So rise and run, this is 3/1. So pick a point, right? Rise up 3, run is 1. Remember, your run always goes from left to right. And there is my very badly drawn line. Maybe I'll try that again. There we go. Okay, so this is my slope equals 3. Alright, so hopefully you're getting used to being able to draw a line using its slope, and also getting the slope given 2 points. But that's it for this lesson, so try your homework and ask any questions if you have.